So are you guys all from the same school for the most part? Yes. Yes. Okay. Where's your school? Luigi? Midtown. 49th Street. Okay, cool. Thank you guys for traveling up here for the event today. Just by a show of hands, who here is really excited about computer science and programming? Most everybody. I heard that you guys were all CS students, but it's always fun to see who's excited about what they're learning. It's important. And then by show of hands, how many of you guys have heard of creative technology? Creative technology, like the word that's up here. One? That's it? Hey, cool. So I really like giving this presentation because I think we're often told that you're not allowed to be an artist and also be a practical and logical person and make money and like live a happy life. So I like talking about the creative tech space because I think that there's a lot of room there for creativity, computer science, math, building things, fabrications, and it's a really fun space to be in with lots of interesting people. So there's always that question of like, what is creative technology? Creative tech is generally a combination of industries coming together. I promise it is not a word that I made up. Our first New York Creative Tech Week is coming up in May. And it's a lot of people who bring together unexpected elements. So it's something like hardware and imagination coming together. This is a project by Chris Eckert, who's an artist. He's a mechanical engineer by trade. And he fabricates everything from scratch, from 3D printing the eyelids for these eyeballs to painting the eyes to assembling all of the servo motors and retinal tracking algorithms that allow the eyes to follow your eyes until they get tired and they look away. So he makes a lot of these sort of robots that have really weird and interesting interactions with humans, and a lot of that is enabled by programming, mechanical engineering, and creative tech. Other examples are things like software and beauty. So these were pieces by Reza Ali. He uses largely C++ and libraries like Cinder or open frameworks in order to create beautiful graphics using programming languages. A lot of his work has been for folks like OK Go or Dolby or large companies who commission his work for some of their larger events. I know an artist who does similar kind of work who made all the backgrounds for Deadmau5 and got to go on tour. And so I always think it's super cool what some of these things can lead to. And there's also the space of like machinery and magic, so digital fabrications and creativity. This is addressed by a designer named Iris Van Herpen, and she printed this dress using a methodology called stereolithography. This one particular is mammoth stereolithography, so you can see how big the bed is. And the dress was algorithmically created. So using code in a 3D modeling program and then SLA or like large bed 3D printers, you can make things that are geometrically almost impossible otherwise. Also similar is addressed by Francis Batanti, who's a designer. He's an architect by trade, and he does a lot of work in the 3D printing space. So this dress was made using selective laser sintering, and all of the code for the dress was generated according to the Fibonacci sequence. So that's how this whole geometry came about, and it was worn by Dita Von Teese. Cool. So as for myself, I focus on the textiles and electronics space. I started a studio called The Created, so we do prototyping and product development for electronic textiles for companies like Google and North Face, and we build them prototypes and do research and development in the space. This was an article from Wired magazine about The Created, saying that we're investing in the idea that the future of wearables is not miniaturized restoring computers, but rather technology that's woven straight into the stuff we put on every day by necessity, our clothes. And that's really what we're trying to get at. So does anybody here own a smartwatch? A few? One? Okay, cool. Yeah, I think that like wearable technology can be so much more, and it can be in the fabric around us. And smartwatches are great, and we're really curious to see what happens when we keep pushing research and development to have things that are more seamless. So this is an example of a lot of the projects that we do for companies are under NDA, so they're hard to share. But this is a project that we did as a press project with Google and Zach Posen, and then Lupita Nyong'o wore it at the Star Wars premiere. So an image should pop up soon, but you can see the dress animates. So it has an LED matrix. Yeah. But on the programming side, putting together something like this means that we need to be able to, all of these animations were made by girls online using a block-based programming language. So we needed to take the information from that block-based programming language and port it into like the most massive array of bits and bytes that would all map to different RGB codes that we could have the microcontroller process to write something to each pixel on the dress. So there are 201 pixels on the dress. Each frame of animation, or each animation itself is 15 frames long. So we wanted to store 10 animations. You're getting to thousands of little pieces of data, and at some point the microcontroller can't handle it all, so you need to bring in backup to hold extra data, and all of that happens in a programming interface in order to have all of these pieces talk to each other. So something like this, I feel like falls a lot more into a fashion category, but you just can't do it if you don't know how to program or wire up electronics or things like that. So let's get back to full screen. Cool, and these are some of the behind the scenes images from putting it together. Another project that we did was a series of UV or sunlight responsive garments called Photochromia. It was a collaboration with a company called Print All Over Me, and they do digital printing. And the garments change in the sunlight, but basically all of the imagery on the garments was generated using JavaScript and Paper.js, so generated using code. And these are a shape called a petrochoid, so it's a parametric equation. And there's thousands and thousands of vector lines that you can generate in seconds if you have a script doing it for you instead of doing it by hand. So this image here is some of the close-up detail of this larger image. And we had a bunch of these from the scripts that I wrote to generate our geometries from. And some of the other parts of the garments for things like Schrodinger's cat or ASCII, and riffing at these different programming or STEM concepts. And then another project that we worked on was making a heated jacket that we called Kelvin. The main part of working on this heated jacket was making it so that it was easy for fashion companies to implement heating into the garments that they already make. So we used largely textile elements for the circuit. We wrote algorithms that allowed us to be more thoughtful about battery power in terms of heating the body. And we also worked on some prototypes that were responsive. So they had a control loop and a system of thermometers throughout the body, and all of those thermometers would then heat you and cool you, or heat you and not heat you in different parts depending on where you're the warmest and the coolest. And this was an article that came out about the jacket, which was kind of funny. Cool. And then there's also a lot of opportunities for residencies in the creative tech space. And residencies and fellowships, which is basically when somebody gives you money to do whatever you want for a while. It's like the best situation you can ever imagine. The School of Visual Arts in their Visible Futures Lab has a residency, and during that residency, we ended up making this remote control shirt. So it's controlled using a biphasic wire called shape memory alloy wire. It's the same wire that the Manned Vehicle Lab is using to test their second generation spacesuit. So it's kind of funny to see that, in this space, there's a limit to the tools that you can get. And if we can use the same tools as the Manned Vehicle Lab or people working on these really high-tech projects, then we need better tools for this space. But we were looking at this idea of modular clothing. So what if a uniform could change shape? Or what if a worker could really have a Transformers experience from one environment to the other? And for anybody who is interested in some of the more technical stuff, it's basically a processing interface, serial porting to Arduino, sending bits of electricity through shape memory alloy wire for each button that you press on the interface, and processing so you can control where it's changing shape. And then more recently, I did a residency at Autodesk which is a CAD and CAM software program company. So they make programs like Maya and Tinkercad and all of these really cool different tools for modeling and making things. And in their artist residency, they have a really wonderful shop that's out on the pier in San Francisco. So you can be like milling or lathing while looking out over the ocean. It's really lovely. And so while I was there, I looked at everything from scripting lace, so using programs like OpenJS CAD, which is JavaScript for making 3D models, to make these kind of lace-like patterns, to looking at CNC milling different like various materials to make like magnetic textiles of sorts, to printing circuits directly on fabric. So I can show you guys this video. Well, yeah, so the plotter is controlled with Arduino. It's pretty simple. And then it prints this conductive acrylic paint according to whatever program you tell it to print. And then you can attach all of your components, which you'll see later, and it'll conduct electricity, which is kind of fun. So this machine was built using a combination of prefabricated parts, and I kind of re-engineered it to live on a piece of fabric so that you can strap it down to any table and then fold it up and take it with you. So you can see the LEDs lighting up from the pattern that was printed on the machine. Okay, cool. And so something that I like to go over for any of these presentations is stuff that's also more on the business side, because I think to make things work in the creative tech space, it often does involve a certain amount of work on the business end. Like you need to know when to send your invoices, and you need to know the process for onboarding clients, and all of these kind of tools that really give you a lot of freedom to explore different things. So is anyone here interested in business or startups or things like that? You have a few of you guys? Okay. Okay, awesome. So hopefully this won't bore the rest of you, but we'll go through it pretty quickly. So what I do, honestly, is maybe about 25% of making and creativity. I showed you guys most of kind of the fun projects that we've gotten to do in the studio, but it's about 75% planning and following a prompt for someone else, and being able to execute those projects for someone else gives us more time and freedom to execute the projects that we want to look at. So I think it's important to share that even more creative careers aren't creativity all the time. And I think that this is kind of an example of a project that I can walk you guys through to show you what the process is like of following a prompt and then executing something creative based off of that. So a few months ago, someone at Google Creative Labs reached out to me because they were working on making a set of creative covers for the Google On-Hub router. So the On-Hub router it's like your typical internet router, but it's in the cylindrical shape. It's really pretty, you can keep it on your counter, etc. So Google made this and they wanted to show people that it could be beautiful and an art piece. So they reached out to me, and the first thing is sending them a proposal and kind of ideating on the idea, letting them know about costs and timelines, and then following up on that proposal. And once we get the proposal approved, then a lot of it is about designing and rendering and executing in order to get feedback from the client. So these were renderers that I had done in Maya. Maya has an MCLOS simulation, so it will simulate different physics characteristics of materials. And so since we work in the textile space, I thought it was fun to make it look like a textile was kind of draped over the On-Hub itself. So we did a few iterations, sent them back, got their point of view. They ended up kind of liking this ghost-like one that hangs off the side. And so then we started doing iterations. And these are miniature scale prints, and it's really important to iterate digitally and cheaply as much as possible, because if you finish a project, something that costs maybe thousands of dollars to produce and then a client doesn't like it, you can't do it again. So it really helps to get out a lot of the problems when you're doing really early prototyping. So these are some prototypes that were printed. And then once we chose one that we liked, we started printing it on a larger scale. So this is also an SLA printer, but it's more of an inkjet form, printing it in resin. For all of the resin for this project, it was about $700. So this is also why a lot of projects are planning, because if we had charged them a price point that wouldn't even cover the cost of the resin, then we can't keep doing this. So it's very much so about projecting, costing, taking past experiences and planning for the worst, but hoping for the best. And then in the end, we ended up using a white plastic Shapeways print, because we had printed a few of them, and they made an animation for it, and this one was on the Google OnHub website, or showing kind of how the OnHub could take different creative, interesting forms. So that's sort of what a project is like, and then you have your final delivery, and you always want to follow up with the client and get their feedback, because that helps you be better. So these are just some of my tangents and ramblings to wrap up. I think that we're often told that success looks like this linear path. I think that it's certainly much more like the scrambly, crazy path where everybody I know who's doing really cool and amazing and interesting work has failed a lot and has a lot of horror stories. Well, not horror stories, but they have a lot of war stories. And I think that it's important to remember that, whether it's programming or whether it's starting a business or whether it's making new friends, it's hard for everyone. And I think that when we remember that these things are hard for everyone and that they're complicated for everyone, then it's a lot easier for us to go after maybe those creative careers or really challenging programming careers or whatever it is that you're looking for. And with that, with emphasizing or saying that this is hard, I think it's important to share that getting to a place where you can do a lot of work in the creative tech space is challenging. But hard is an amazing, exciting adventure of learning and growing and failing, in the sense that just because things are hard doesn't mean that we shouldn't do them. And I think that pertains particularly to programming, where when you have this bug, you just don't know what's wrong, you can't fix it, it's 3 a.m., you're super frustrated. I feel like that's the point where you're living at the limit. That doesn't mean that you're a bad computer scientist, it just means that you're pushing yourself. And speaking of pushing yourself, there's this great article by Paul Graham, who's kind of this Silicon Valley guru of sorts, and basically the overview of this article is the idea of working hard on hard problems is the best thing that anyone can do for themselves, in the sense that he's saying at least that in fact, I suspect if you had the 16-year-old Shakespeare or Einstein in school with you, they'd seem impressive, but not totally unlike your other friends, saying that people who do extraordinary things aren't necessarily different than you or different than the people you know, but they tend to just work on really hard problems, and they tend to work persistently on those over very long periods of time, and that makes the hugest difference. So that's about it for my presentation. If you guys have any questions, thoughts, please feel free to email me. I know we have some time for Q&A today, so happy to answer any questions that you might have now. Let's see. Any questions? Yeah.
So the object that you were putting over the fabric, was that a little miniature 3D printer that was on the rails and had a little belt? When you were putting the injection into it, or that little needle that was going into it?
Yeah, so it's not necessarily a 3D printer because there's no Z-axis, but it's a syringe extruder.
Oh, exactly, right.
Yeah, so it's a 2D syringe extruder plotter.
Okay. What was the material you were using on that?
Yeah,
the filament or the...
It's liquid, so it's conductive acrylic. You can buy it from a website called La CMF, which sells conductive items for people who are worried about electromagnetic frequencies. It's this super weird website. You've probably been on it.
So you were making a circuit in the shirt. Is it in the fabric, right?
Yeah, so that circuit was printed directly onto the fabric, and we just built a new machine in the studio that's compatible with silver nanoparticle material. So this material that we were using was super fragile. So we engineered a new material, and now we can print much larger, much more accurate, less blobby circuits on fabric.
It was really cool.
Oh, thanks. Yeah.
What is your educational background? What did you study in high school, and how did that lead to what you were studying in college?
Yeah, of course. I did a general liberal arts education when I was in high school. I was particularly interested in fashion, so I went to Parsons for a semester, and then I'm an awful influence. I left school and I did this program called the Thiel Fellowship, which is basically a grant to leave school for 2 years and start a business or like do something else. So I'm still in the process of exploring that. So, yeah.
Is there any connection with technology and food?
Oh, absolutely. So we just hired an engineer who's a 3D food printing expert, and he basically builds machines that print like yogurt and hummus and different foods, and it's the coolest experience to hold a cracker and have this machine like decorate your cracker and then have that experience of enjoying it. So there's like stuff on the mechanical side. Also, in terms of molecular gastronomy, if you're interested in science, there's especially now like more of a scientific movement around the food space of capturing taste and scents and smells in unusual spaces. So I think that there's a lot around food, and it's a human experience to love and enjoy food. So I think it's very cool that you're interested in combining the two.
I'm just really hungry.
So you're like, I'm not that. Actually, me too. So I'm with you there.
Thank you.
Of course. Yeah.
You said you worked with Google on that project?
Yeah, for the Zach Posen dress and also for the on-hub router.
So what other companies did you work with other than Google?
Sure. We've worked with North Face, American Express. I like it's hard because like some of the client things are under NDA, so we can't really share them until they come out. But we work with much larger companies who are working on projects in the space. Yeah.
Can I just make a quick comment?
Yeah.
It seems like you had to do like a lot of like creating your own opportunities by going out and seeking out like fellowships or internships. Is that how you like the idea that success is a straight line? Was this what you had? Would you do you have any words of encouragement to these high schoolers as they like sort of think about their next careers and like in order to like I don't know to feel like you're moving forward or something, even if it's if it's not like a traditional pathway?
Yeah, absolutely. So I feel like there's so much depth there because I feel like we tell people that it should be easy, and then when it's not easy, then they feel like they're doing something wrong. And I've done so many residencies and fellowships and applied for so many things that I didn't get, but nobody cares about the ones that you don't get, and people only really care about the ones that you do, and then when you get one, it's a lot easier to get others. And I think that especially when you're young, people are so much more willing to give you opportunities and help you because you have so much room for growth. And so I think that around this age is the time to be applying for an internship. It's the time to be working on personal projects. Personal projects are huge. Like having a portfolio to send people to makes a really big difference. And now you have time to do that. It's really different when you need to pay bills and do your own laundry and like do the whole adulting thing and also work on personal projects. So I think now is a really good time. There's also just the concept of mastery. So even developing a good aesthetic takes a lot of time, and if you start working on those things now, you'll just write better code when you're older, you'll design better things when you're older. Yeah, I think that now, or like my first internship, or it wasn't my first like New York internship was at Tommy Hilfiger when I was either 17 or 18, and I found that internship because I emailed like 100 people on a press list. And it was this old press list. I just emailed them all being like, are you looking for interns to do like free labor? I'll do whatever you want. I'm super excited to work for you. And I heard back from Betsy Johnson, Tommy Hilfiger, and one other company. And nobody remembers the 97 companies who saw my email, like either laughed or ignored it or like printed it out and hung it on the wall and like made fun of me, I don't know. And then you just hear about those three and you move forward. And I think that it's important to keep that in mind, that like 97 people may say no, and you just have to find those 3 opportunities that say yes and go for those.
Thank you.
Of course, I hope.